Does gravity only exist for heavy objects like planets? No! You just only notice those because, maybe I'll spell the word right, because the masses are huge. So, does gravity exist between you and your partner? It absolutely does. You just don't notice it because your mass isn't big enough. Okay, your mass isn't big enough. So, does gravity only exist for heavy objects like planets? No. It's just that's the only ones we notice because they're large enough. Okay? That's why you can feel gravity on the moon. That's why you can feel gravity on the Earth, because their masses are big enough. All right. Sweet. Jump to the back page. Look at that. Only 4 more. We're almost there. And then I'm going to show you videos to take a break. Okay? I'm going to show you some videos about gravity. Okay? Review. What is weight? It's the force of gravity. What determines how heavy you feel? It's not the force of gravity. It's the normal force. Remember from the elevator problems we did. What you feel is the normal force. You don't feel gravity. You feel the normal force. So when the normal force is large, you feel heavy. When the normal force is small, you feel light. So if we look at this example with the elevator, when you feel a normal weight, it's because your net force is 0. When you feel heavier than normal, it's because there's a net force up. When you feel lighter than normal, it's because there's a net force down. And then we'll talk about when you feel 0 weight, when you feel weightless, what that's like. But first of all, we know that there's a force of gravity on all these things. And the force of gravity is the same every time. Fg down, Fg down, Fg down, and Fg down. And you'll notice my arrows are all the same length. So, when force of gravity equals the normal force, you feel the normal weight, and that's because the forces are equal and opposite. When the net force is up, you're going to have a larger than normal force. When the net force is down, you're going to have a smaller than normal force. So what do we think if the net force is 0, or sorry, if we think that we're weightless? So we feel heavy when the normal force is large. We feel light when the normal force is small. What if we felt nothing? Correct. So why do astronauts feel weightless in space? It's because the normal force on them is 0. The reason why astronauts feel weightless is because the normal force acting on them is 0. In other words, they're in free fall. Being weightless in space has nothing to do with gravity being small. In fact, gravity isn't that small in space. Your weight in space is almost the same as your weight on Earth. I think the acceleration of gravity on Earth is 9.8. In space, it's like 9.0 at where the space station is, which is smaller, obviously, but not ridiculously smaller. So why is it that you don't feel weightless? Or why is it you feel weightless? It's because you're in free fall. You're falling around the earth. You're not falling into the earth. Yeah, you're falling around the earth. So I'm going to show you something that Isaac Newton came up with. Okay, I wish I could say I came up with this example, but this is a Newton example. He said, what if you put a cannon on Mount Everest? What if you put a cannon on the top of the tallest mountain? And you fired the cannon forward. It would go a little bit, and then it would hit the ground. Then you fired it a little faster. It would go a little further before it hit the ground. What if you fired it a little faster? It would go further before it hit the ground. What if you fired it at the perfect speed? It would go all the way around the earth and come back and hit in the place it started. That's what the International Space Station is doing. The International Space Station is going so fast that it goes around the earth. And you might be saying to yourself, well, that doesn't make any sense. It's not. Why would it move in a circle? Well, it has a tangential velocity. So it has inertia in motion, has some forward inertia. And gravity pulls it towards the center of the earth. Oh my gosh, that's a centripetal force. It's circular motion. Gravity for planets and moons and satellites and space stations, it's just circular motion. It's applied force that's a centripetal force that causes it to move in a circle, and it's inertia in motion that causes it to go forward as it goes around. So the space station is at a free fall, so it's constantly going around. And so that kind of explains this idea of weightlessness. So let's look at a couple of examples to kind of hit on this. Any questions on this stuff?